Hello and welcome to the Pattern Texture Workflow Guide. This workflow has been completely overhauled to make pattern cleaning mostly automatic. However, we wanted to ensure you still have control, so we've included preferences that allow you to adjust how the cleaning process takes place. These preferences may take some time to get used to, especially because we've added several different cleaning algorithms, each with its own perks. In this guide, we will showcase the basics, but if you want to master this tool, you should refer to the documentation, where we explain the underlying logic for a deeper understanding. Whatever settings work for one model may not work for the others, which is why a deeper understanding can benefit you. Now, let's work on this tank, which clearly uses a pattern texture. It also contains some solid regions, but that's fine, as the pattern texture workflow is designed to work with models that utilize both patterned and solid regions of the palette. Before we get colors, let's disable the Auto Cleaning Patterns option to see what the results look like so we can get a deeper understanding of what they do when they are enabled. As you can see, by default, we get a warning message. The number of colors and merged colors is 813, which exceeds the limit set of 500. This will prevent colors from being displayed in individual mode to avoid crashing or lagging, as the editor is not equipped to handle data of this size. That said, we can increase this limit from 500 in the settings. Let's set it to 2000. Now, when we return, we can indeed see all of the colors. However, the editor is lagging due to the vast number of colors, and with Colorize Original, you had to clean all of these colors manually. Obviously, this is not ideal, and that's why we have added auto-cleaning algorithms. Let's get colors again, but this time, we'll enable auto-cleaning and use the default technology, PFC, while using the default auto-cleaning strength of 3000. PFC technology groups and merges the noise pixels generated by anti-aliasing, smoothing, and compression algorithms. However, this technology is still in development, so we may need to inspect the results to determine whether manual intervention is required. As you can see, though the majority of the patterns have been cleaned adequately, not all regions are perfect. These regions, which appear to line the edges of the patterns, are the result of what used to be noise pixels that have been merged together. However, instead of all these noise regions being merged into a single region, they have been merged into 4 different regions on this occasion. But that's fine. We can select all 4 and merge them together using the merging tool. And just like that, we're done. Now, it's worth noting that this region lining the edge of all the pattern textures did not exist in the original texture, or at least it wasn't visible to the naked eye. This means that PFC technology has some shortcomings, but we've kept it because, based on user feedback, the side effect of this technology can sometimes be desirable. But worry not, because we've added other technologies, such as PFVC. This technology is our most refined at the moment, and the difference between PFVC and PFC is quite simple. PFVC redistributes the noise pixels back to their neighboring patterns. Effectively, this reverses the effects of anti-aliasing, smoothing, and compression algorithms. Though these algorithms are considered lossy, and returning the texture to its original form may be impossible, that doesn't stop us from achieving desirable results. For that, we have 2 methods: redistribution based on neighboring frequency, and also based on neighboring variation. The latter is the one we believe is more accurate. However, both methods will make the texture look different, and it's up to you to decide which one you prefer for your style. But before we get colors, there is one more variable to consider with PFVC, and that is maximum search depth. This variable determines how far a noise pixel will look within its radius to find a parent group for redistribution. We recommend using the value 3 to start with, as this value can significantly affect the outcome of how your texture will look. You may need to use some trial and error to find the results that best suit your style. Now, let's get colors based on these settings and inspect the results. As you can see, we have eliminated all noise pixels, and this is why PFVC is our go-to algorithm for solid pattern texture cleaning. We have also added 2 more algorithms, but they are experimental, and we don't recommend using them regularly. However, we've included them because, in some rare cases, they can provide more desirable results. For more information, please refer to the documentation. Thanks for watching, and see you in the next guide, where we cover the Pattern Segmentation tool, a tool that takes pattern editing to the next level.